Good morning, everybody. We're going to be working on page 34 today, and we're going to be working on Lesson 5, Module 4, and we're going to be focusing on using circular protractors to understand degrees and understanding fractions as well. So before we go into this lesson, I'm going to give you a preview of how we're going to use this circular protractor to help us solve for 360 degrees. So, just so you're aware, this whole circle as degrees is 360 degrees. Okay? So when we have a full circle, it is 360 degrees. When we cut this circle in half, it almost looks like a Pokeball from Pokemon. When we cut it in half, we have 180 degrees here and another 180 degrees here. Right? So 180 and 180. And that equals 360, right? 180 and 180. So that's why when we say we have straight lines, it makes 180 degrees because it's half of 360. All right, now let's go further. And let's make a vertical line, horizontal, and let's cut this in half again. So now what we've created is right angles. We've created right angles, and now this 360 degrees has been cut up into 90 degrees, 90 degrees, 90 degrees, and 90 degrees. And that equals 360 degrees. Now, with this, we can go even further with one of these measurements. And I'm looking right here in this area. And I can actually cut, and this is not going to be perfect here, but I can cut this 90 degrees in half, and it'll make 45 degrees. It'll make 45 degrees and 45 degrees. So that's how we know is a 90-degree angle is cut in half, and that makes 45 degrees. Or I can even go further and cut 90 degrees into thirds. And this is not going to be as perfect as I want, but we can cut it into thirds here. And I'm going to have 30 degrees, 30 degrees, and 30 degrees here. Okay, cut into thirds. And this still all equals 360 degrees. It's just I've cut it into different parts here. This is definitely 90 and 90, but this 90 here, I've cut it in half to make 45 and 45, and this 90 here, I've cut into thirds to make 30 degrees, 30 degrees, and 30 degrees. Okay? So just so you know, this is how we can use our circular protractor to understand degrees today. So let me backtrack and just kind of review what we did just right now. So what I did was I cut this 360 degrees in half to make 180 degrees and 180 degrees. Okay? And then I went even further and I cut it in half again to make 90 degrees. 90 degrees and 90 degrees. And we can even go further and we can cut this 90 degrees in half to change it from, actually I'll do it right here, to change it from not 90 anymore, but to 45 degree angles. Okay. Or we can go further and we can cut these 90 degree angles into thirds. Boom, and boom, and that's going to make 30 degrees, 30 degrees, and 30 degrees. All right. So that's what we're going to be working with today. We're going to be using that circular protractor to help us solve today's problems. And we are going to be using these degrees in fraction form for this back page. And I'll show you what that's going to look like using this circular protractor. Let me go back to 180 degrees. So if we have 180 degrees here, I am going to literally put this as a fraction as 180 degrees. It's 180 degrees under 360 degrees. This is what this fraction would look like. If I had 90 degree angles here, if I had 90 degree angles, right, 90, it would look like this. 90 degrees over 360 degrees as a fraction. So we're going to be using this fraction form to describe our degrees and our angles compared to 360 degrees, which is the full circle. All right, so let's get into this. Let's get into these first couple problems here. I'm definitely going to kind of make that a little bit smaller so I can use it in that corner there. And let's zoom in on our first couple problems here. Awesome. So we found out today that 1 degree is 1 360ths of a degree. So if we have 1 degree, it is 1 360th of a degree, of a whole turn. So it is 1 out of 360 degrees. That means a 2 degree angle would be 2 360th of a whole turn. So what fraction of a whole turn is each of the benchmark angles you listed in problem 1? And if we go to problem 1, we had A as 45 degrees, and we had B as 90 degrees. So what would that look like as a fraction form? Well, that's pretty dang simple. I mean, we are just going to say it's 45 degrees of 360 degrees, and then we're just going to say it is 90 360ths of a degree. So for this one, this is very simple. It is a simple problem here. Now for number 6, how many 45 degree angles does it take to make a full turn? Now this is interesting. So how many 45 degree angles does it take to make a full turn? Well, let's use our circular protractor to find out. So I am going to cut this in half. Oh, sorry. So I'm going to cut this in half. Okay. And I am also going to be cutting this again to make 90 degree angles, right? And so, yeah, because this is 90, 90, 90, and 90, right? 90 degree angles on either one of the, or on all of these. And to make 45 degree angles, we got to cut these in half, okay? So we're going to cut these in half. So let's do it. So we got boom, 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 and boom. So let's count how many 45 degree angles we have here. We got 1, 2, 3, 4, 5, 6, 7, and 8. We have 8 45 degree angles. Now I'm just gonna be checking this math here. I just want to make sure that I'm right. So I'm going to do 45 times 8. And if it does equal 360 degrees, which is the full turn, we are accurate. We are definitely correct here. All right, so 8 times 5 is 40. And then 8 times 4 is 32, plus 4 is, 360. So how many turns does it take? It takes 8, 4, you know what, let's spell it out because that'd be better. So it's 8, 45-degree angles make a full turn. All right, excellent. Now, what I would like for you to do now is for 7 and 8, I'd like for you to do on your own, but I'm gonna give you some assistance here in solving this on your own here. So we just did 45 degrees on 6. They want to know how many 30-degree angles does it take to make a full turn. So I'm going to be making a 30-degree angle, and you can make this as well for your circular protractor. So let's cut this in half to 180 degrees. Perfect. Let's cut it again to make 90 degrees. So we have right angles, right? These are 90. And I believe I demonstrated this for you when we were talking about 30-degree angles. But remember, if I cut a 90-degree angle 3 times, right, 3, 6, 9, it's going to make 30-degree angles, right? $30, $60, and $90. Okay? So I would like for you to finish that out. Tell me how many 30-degree angles does it take to make a full turn. And I would like for you to use multiplication, just like we did for 6, to see if it is accurate, to check your answer, see if it gets to 360 degrees. All right. And your final problem today, if you don't have a protractor, how can you reconstruct a quarter of it from 0 to 90 degrees? So when we have 90 degrees here, how can we make a quarter of that? So what that means is that we're going to be cutting it into fourths. And what happens when we cut this 90-degree angles into fourths?